Imagine this. You're at the beach, building a sandcastle near the waves. You find a pretty rock and throw it in the water. Splash. It sinks right to the bottom. Now look at that big boat floating by. How can something so heavy float when your little rock doesn't? Let's dive into the mystery. First, fill a toy bucket with water and push a little paper cup onto the surface. You'll notice it bobs up and down like a little ocean dancer. This is because of a cool scientific principle called buoyancy. Buoyancy is the force that helps things float in water. So, why do some things float while others sink? It's all about how heavy something is compared to the water it pushes away, or in fancy terms, its density. Imagine squeezing a sponge compared to a rock. The sponge is light and airy, but the rock is heavy and solid. Boats are kind of like enormous sponges. They might be hefty, but they've got lots of space and air inside. When a boat enters the water, it pushes away a big amount of water. The water gets back at the boat by pushing upwards, helping it to stay afloat, like it has a team of little helpers. But a rock, oh dear, it's solid and has very little air inside. It doesn't push much water away. With more weight than the water can push back, it's got no choice but to drop down. The story of boats and rocks is like a puzzle solved by a brilliant scientist long ago. His name was Archimedes. One sunny day, while in the bath thinking about things that float and sink, he noticed how the water level rose when he settled into the tub. This was his eureka moment, a legendary tale of discovery. So, next time you toss a rock in the water, remember the clever trick of buoyancy, a weighty boat floating while a pebble sinks, all dancing to the tune of water density and the upward push of buoyancy.